Hello everybody. In this video, I will present a topic called identifying metadata-specific collocations in Text Corpora. My name is Vojtěch Kovář, and this is a joint work with Ondřej Herman and Miloš Jakubíček. All of us are from Natural Language Processing Center and at Masaryk University and Lexical Computing. I will proceed with introducing the initial goal, the initial idea that we had in mind when starting this work. Then I will spend most of the time of this presentation by introducing the formula that we proposed for this task, for identifying specific collocations, metadata-specific collocations. And then I will show a bit of implementation and some examples. So what is this work about? We would like to say, for example, when a user or when you are viewing word sketches, that some collocations may be specific to some text types. For example, if we look at word sketch of bat, we would like to say that baseball bat is usually used in sports domain, whereas bat wing is usually used in zoology, and bat file, maybe some mistokenization, is used in computer texts. Similarly, in topics like oil, we would probably like to see that oil painting is typical for art, whereas oil spill is usually ecology. There are of course some like very clear collocations specific to domains, but in other cases it may be also surprising, and we may need to know. So we would like to join the collocations together with corpus metadata distribution, and we would like to show the results for a word sketch user, so that he or she can make use of it. It is of course something that is already possible, but it requires a lot of clicking, and I really doubt that somebody is actually doing that. The initial idea is that if some large percentage of occurrences occurs in some text type, I say X in the slides, but you can imagine that it's zoology. For example, if more than 97% occurrences lies in zoology, we would say that the collocation is always used in zoology. If the number is still large, but it's not close to 100%, we would say that the collocation occurs usually in zoology. Of course, there is one significant problem, that the text types in the corpus are rarely evenly distributed, and for some text type covering most of the corpus, like written text type in B and C, it will be always reported, whereas a small text type, for example, covering 10% of the corpus, would be almost never reported. So this is very undesirable. So this leads to the first straightforward correction that we investigated, and that is normalizing the numbers of occurrences by text type sizes, which means not working with absolute frequencies, but with relative frequencies across the text types, and comparing relative frequencies across the text types. However, there are new problems with this approach. The first one is that small text types are given too much weight. For example, if we find 20% of hits in in a text type covering 5% of the corpus, it would result, or it would often result in label usually X, usually zoology, if zoology covers 5%, which is an inappropriate label. It's proper. Sorry, it is probably something to be reported, but not as usually X. Usually X. Another problem is that if the collocation is significant for more than one text type, but but it is still not general collocation. It is specific only for two or three text types. Like in this scenario, half of the hits is in one small text type, another half of the hits is in another small text type. We would report nothing because the relative frequencies wouldn't exceed this arbitrary 70%, and that is not okay that we don't report anything. We would like to report anything because the situation is interesting, and we'd like to fix this as well. This led us to a second correction of the formula or of the statistics, which is to compare expected and observed frequencies across text types. We would compute the expected frequency as a relative frequency, as the relative frequency in the whole corpus, multiplied by the text type size. And if observed frequency in the text type is much higher, we would report this. We would of course introduce some thresholds so that we make sure that the result is statistically significant, and much higher in our case means 2 times or more higher frequency. We were happy with this formula, with one exception, that always and usually the labels that we started with are not good descriptions here. So we came with another label which says especially X, for example, especially zoology. So the bat wing would be marked especially zoology, and we feel that this label is much more appropriate for this situation. For example, when 20% hits is in 5% text type. However, we haven't given up the labels that we started with, always and usually. Rather than that, we returned back to the original idea and based these labels on absolute frequencies, which is as listed here, with one exception, and that is the dominant text type. If there is a text type covering more than 50% of the corpus, we would simply take it out from this evaluation, by which we avoid this problem listed here. The second problem listed here is already fixed by the especially label. And for the dominant text type, we do an even more like elaborate thing. We compare expected and observed frequency in the rest of the corpus, and if the frequency is much lower in the rest of the corpus than in this dominant text type, we will report usually or always this dominant text type. Again, we introduce some thresholds, and much lower means 5 times or more. All the thresholds introduced here in this talk are rather arbitrary, maybe initial, and maybe subject to future change, but they were like just initially picked up, and they seem to work reasonably well so far. The labels are indexed in the word sketch indexes, so they are created. The numbers and the labels are created when the corpus is compiled, and they are saved with word sketches. They present a conservative increase or in corpus size on BNC with three text types. We measured something like 20% increase in corpus size. And at front end, we show the labels as discussed directly at word sketch collocations. You will have to turn it on in view options if you want to see them, and the information is also available in the Sketch Engine API, so that it is available to external tools and probably to some post-editing or lexicographic projects. Here are some examples. You will see that to be able to make some use of it, you firstly need to understand these labels. This is BNC and the text type called David Lee's classification, and you can see, for example, that bad news is typical for tabloid newspaper, whereas good news is specific for religion and quite a lot of other domains. All oil paintings are typical for popular magazines. Oil spills are a political topic, and oil prices are a commercial topic and political topic. It is interesting that oil spills are not commercial topic, but it's kind of typical, I would say. Here is another example with another text types that are, I would say, a bit more readable. This is from Estonian National Corpus, and there are some specific collocations. For example, this means something like regulation in the head word is kas, which means cat, and this means that this means regulations in regulations for cats and pets or something like that. So this is another picture how it can look like. To conclude, the main conclusion here is that there is a new feature. We have invented a new formula and related statistics that are, we can say, not trivial, and the usability, as always, depends on corpus data, and namely metadata. It is not only the labels that we were discussing that should be somehow readable, but it must be also informative. So the document classification needs to be sensible. Thank you for your attention, and looking forward to discussion at the conference.